Hello, everyone. Um, this is going to be kind of an overview of particle systems. Um, One thing that we'll kind of go over first is UJA. So if you go to your Canvas, you click on UJA video, what you can do is, excuse me on that. What you can do is you can actually say you create your video, so you could go up here, click create recording, and then you can screen share and that type of stuff. Um, but what you can do is then once the video is done recording, you can go to more, you could go to links, and you can get this public access direct link, or you could go to downloads and then request to download to the media, and you could do single file, and that will give you your video as well. So say, for example, we wanted to test if this video is public, what we can do is we go to new incognito window and paste it, and boom, you can have access to the video, and this kind of just make sure you have video access, or we can access that video and it's not private. It shouldn't be private. If it is private, I would Google it, but I think it may be in security. Yeah, in security. So if you go to your links, you go to security, make sure it's public. And yeah, so that's kind of just the overview of UJA video. Hope if there's any issues or struggles with kind of what what's happening with UJA video, then you can always message me or Rix, and we can kind of guide you through it on during class time to make that transition a little bit easier. Okay. Now with that being said, I think we shall start particle systems. So as we see, what we have right now, we have our game, we have all of this behavior tree that we did last week of both of these, and then we implemented like this projectile shooting creature. And now what I did during class while implementing particle systems was I did this, where we kind of generate a particle system. But obviously, if when you look at it, it's not the greatest. You know, it goes into the ground. You see some particles go through the ground. Um, they look fake, like everything is affected by gravity, but there isn't no what's the word? There's no like pull force downward, so it just feels like little chunks just flying out into outer space. Which maybe some may want that, but we kind of want that option to apply that gravity. So there's a couple things that we will do. Um, One of the first things that I think is probably the most useful is direction. So as of right now, what we have is well, let's first actually go over how I instantiate it. So when I instantiate it, what I do is I instantiate a new game object called slamming ground game object. And that and you put in the clone of your current position of the player. And this is just a particle system with some variables. Say, for example, one thing you wanted to do was make it so that um, you want it to follow. So say, for example, you're doing a spaceship and you have thrusters. What you would have to do is you would have to have a new component. And this would be like a new follow follow player thrusters. And what you would do then is you would try and get that player game object, and then you would get the position of the thrusters, and then you would just set that transform to this particle system, or this particle system game object transform. So you wouldn't do it inside of the particle system. You would have a separate component that controls the game object that is changing the particle system's position. But yeah, so now I just have a component where we have 10 to 20 particles. Velocity starts between 2 and 3. The lifetime is between 0.25 and 1, and particle size is 1 to 2.5. and the particle color is between white and black. So, but now we want to kind of update this direction. So I think that the um, obvious, not obvious, but one thing we can do is kind of follow the same pattern of particle direction equals new. And we want, so since we kind of have a math.random already from 0 to 2 pi, what we want is we could do a uniform distribution where it is from 0 to math.pi times 2. So now we kind of implemented particle direction into the distribution, and then it is now as simple as when we do color, we also now do direction. So if we do direction, this dot, well, where is it? Particle direction dot sample. So now when we look at it, that should be kind of the idea. Now, when we actually look at it now, though, we kind of need to use it. So obviously, direction is already variable, so we don't need to worry about that. But what we need to do is particle in here is going to be a new uniform distribution. And what we need to do now is we need to give it 2 points, and then it goes between those 2 points. Obviously, we're in radians. And so obviously going left is 0, down is pi over 4, left is pi over 2, I think. And so on and so on. So I think what it needs to be is between math.pi, which would be the left going left, and math.pi times 2. So only go upwards. And now let's just test it out. Now if we look, now all the particles go up. You saw that there really isn't a particle going downwards. So now that's kind of good. Yeah, but now I think they look a little bit weird just kind of hanging out without any kind of input or force pulling it downwards like everything else. So the next thing is to implement some sort of gravity. This is a little bit, there's kind of a couple ways to do it. Obviously, we have a rigid body system, but if we put a rigid body onto our game object, so if we do this dot add component, and we do a new rigid body, it's going to actually make the game object itself a rigid body, which means that it will change the spawn position and that stuff. Which that may be what you want, but that's not what I want. I want it to stay at the same spot. It's just the particles are now affected. So, what we can do then is inside our actual particle logic now, we can kind of implement a pseudo-gravity type of ordeal, where now we have a gravity equals 0. When we assign it, we have the start time. And then we have the this dot vx and vy. This is how I do it because now the velocity times cosine times direction is always constant. As far as right now, you may want to change that. So you may want to adjust it based off of time. So what you do is you would have to reference start time or like some sort of duration variable. We won't be doing that, but it would be as simple as multiplying it by some sort of multiply some over like time left, or for example, and then that would kind of scale it downwards as it goes out. Um, but the was I going? But what we need to do now is we actually now need to do uh this dot vy, and we plus equals this dot gravity. Now we're applying that gravity downward, and then yeah. Now the next thing we need to do is we want to make sure that we have a particle gravity. And that equals a new, and we want a constant distribution of 0. And then this means that inside of here we need a gravity this dot particle gravity dot sample. So nothing should change because what's happening is that it is still gravity is 0. But now when we go back, what we can actually go into here is do a very, very, very small gravity. So if we go back here, do particle gravity, and then we want this to be, or I want this to be a constant distribution, and I'll do something like 0.1, and we'll kind of see what's happening there. And all of this is just testing and kind of that type of stuff. But we go over, we slam down. That seemed like a little bit too much, so we can just have that, and then we can kind of go onwards. And that felt really, pretty good. And it isn't a perfect system, so like we would probably want to match um, a little bit more to our what was it called? If we want to match a little bit more of a rigid body, there'd be like time dot delta time and that type of stuff. But I found this to work relatively well. Um, the next thing, see, so one kind of cool thing about particle systems is that, or one way you can do it is have it a continuous spawning, and then you could also have like a way to maintain particles. So we can start with that. Let's do maintain particle count. And that equals, let's just say that equals false. You could also make this a distribution, but you could make this a constant or uniform distribution, but you would have to have some gateway logic in order to determine that. But what we would want to do is we would want to say, hey, if we want to maintain particles, when we filter the particles, if we basically destroy a particle, we need to spawn a new particle. So let's first kind of get the difference in particles. Let particle count difference equal this dot start particles dot sample, and we want to get minus this dot particles dot length. So one thing that will kind of be apparent is that we don't have a way. So this is what I personally would do. So when we call this sample, if it's a uniform distribution across like 5 and 100, the start particles dot sample and this start particles dot sample will be different. So you could always say something like this dot start particle count equals this dot start particle dot sample. And now we can actually reference this throughout. So hopefully now we can do that. And then we can say, hey, instead of getting a new sample, we just say start particle count. And then what we do is then if if we want to do this dot maintain particle count and particle count difference is greater than 0, we need to spawn particles based off of um, or we just need to start spawning particles. But instead of based off of this dot particle count, we need to do particle count difference. And now what should happen now is it should spawn particles based off of that amount. What you could do is you could make a function that has an if statement or that has a for loop and particle count. Um, so like you could have a draw particle amount of particle amount, and then you could have this. So now you could just call draw particle. And the amount would be this dot start. And let's just comment this out to make sure that I am doing that correctly. And it would be the same thing for this. We could comment this out. And we could do something like draw particle count difference. Hope it's this time. Just to clean it up more and kind of make it a little bit better. And now if we start. Okay, so we know that works now. It didn't spawn any because we didn't adjust that start value. But I think that we can kind of get rid of this now confidently. And now inside of our slam and ground game object, we can do maintain particle count. And that will be true. And then when we kind of look at this now, and you see when they kind of destroy, then they respawn again. And they kind of continuously do this since the lifespan difference isn't that big. It kind of does in clusters. So if you make a lifespan from like 0.25 to 2, that will probably make it a little bit more sporadic over time. But yeah. The other way you can do this is you can set this equal to a constant distribution of 0. And then rather than doing start particle count, you do the sample of it. So you would, so say for example, I want to start with 10 particles, but I want just to spawn more at the very end or something like that. Which that's kind of a different thing. But say you wanted to maintain a higher particle count. As time continues, you can always maintain a distribution. Get the maintain particle count distribution, and so you would do like this is kind of just a general idea, but you would do this dot maintain particle count, and you would equal or sorry, this dot max particle count equals this dot maintain particle count dot sample. And what we would do is we would use this dot max particle count instead of the starting point. And then we would also have to check if the other way you could word this is oh yeah, this would work. What you would do is then you would get your max particle count minus your current particle length, and you would instantiate based off of that difference. But that's just That's kind of a not the standard way to do it from my understanding. There's a better way to kind of add more particles as time continues type of ordeal, um, which we will start doing next. So this is, I call this the continuous on particle count. And we just want to set that now to a new constant distribution of 0, because we don't want any of that. And then let's just have another variable called continuous bond interval. Um, yeah, and this is a little bit, and let's do a new constant distribution of 0. Oh, what is this supposed to do? Well, what we want to do is we want to kind of have some sort of way so um we need some sort of time interval based off of our continuous what's it called? Continuous spawning interval variable. Um, and what we want to do is first we want to kind of get we don't want to just always assume that the interval is constant. So first we want to get the sample of the continuous spawn interval and set that to equal the current interval. And if we want inside of here, we want to do something like, hey, if our this dots oh, our spawn timer, which is just a spawn timer equals 0, so this dot spawn timer plus equals time dot delta time. If this spawn timer is greater than or equal to the this dot current interval, well, and the current interval is greater than 0, because what happens if the current interval is 0 is that it kind of just always spawns, and that's not the you could also change this to greater than or equal to if you want to allow a 0-second spawn interval. It just will be a lot of it'll just be a lot. But what we can do now is then we can um what's it called? Call draw particles based off of the this dot continuous spawn particle count dot sample. SAMPLE. Oh, sorry, this dot draw particles dot sample. And then what this will do is it will draw particles based off of the continuous spawn rate. After we have some sort of current interval, we need to then reset this dot spawn primary equal to 0, and then you can set this dot current interval to a new this dot continuous spawn interval dot sample. And with this now we should be able to continuously spawn. So say for example we want to keep this false just because we don't want to maintain particle count and then also spawn this extra stuff, but we want, where's it at? Continuous spawn interval to be a value, and then continuous spawn particle count to be a value. And let's just do a new uniform distribution. And let's say just it's 1-to-1 for right now, just to kind of get that. And we have a constant distribution of 5. Or we could do a uniform distribution of 5-to-5. And then we need that, and we need that. So now every kind of 1 second, we spawn 5 particles now. Okay, there is an error. It's usually after a. That is interesting. Let's do just a constant distribution of 5. See what happens. I don't think it's this. Oh, I think what's happening is that it is saying, hey, if our particle length is less than or equal to 0, so I think what's happening is that it is spawning everything. Okay. That makes sense. So I think the easiest one to do is just have a flag, continuous particle spawning equals false, and this dot continuous particle spawning, that equals true, and we just implement that in here as well. So then if the other way to do this is you could probably reference your continuous spawn particle count. So if you get a sample of it and it's not 0, you could probably continue with it, but having this flag probably just makes it a little bit easier logically. Um, but, so now you see it's just continuously spawning particles. And if you really want it to be crazy, you can always, let's say we, instead of doing a continuous spawn interval, let's do 0.25 to 1. And now it's kind of like a flickering. So say you have um, a door that's locked, or a kind of some other things. You could always have it kind of flicker in this random interval. I don't like the size. I think the interval is too big, so we can even do like 0.1 to 0.5. And then you kind of have this like constant stream of particles. So yeah, so say for example, we wanted to do the blast or the movement. Um, it could just be something as simple as now always fire it. Um, um, and have this continuous spawning in the whatchamacallit. You implement this continuous spawning whenever you move or if you're in space. Um, so yeah, so that's kind of the core kind of stuff that I wanted to touch on. Um, what else? Let me think. I think that is it for me. I think those are the core ones. One thing you could also always do is look up Unity particle system. Um, we will. as you can see, if you don't even have Unity installed, and you don't, there's a lot of stuff you can do. So like there's velocity over lifetime, there's delta time, there's some of the stuff that's more Unity specific, but there's like a start delay, start speed, start size. Um, and there's a lot of stuff you could rotate. There's collisions and triggers, which are kind of like event handling for triggers, is my understanding. You could do lights, trails, like there's a lot of stuff possible. Like for example, one common thing a lot of people do is fireworks for particle systems. That's kind of a good introduction. So if you don't fully understand particle systems, or all would be, or you want to include particle systems, but it's kind of just a niche thing. When you beat the game, you can include fireworks, and the way you do fireworks is it's more of something of you'd have two have big picture. Let's kind of do the we could uh, we can do it inside of parts. Um, like how to do fireworks. This is kind of one that you could do. The core idea is you would have two game objects. One be like the launch particle. So you have one game object that would be a particle system, and you could say it fires one particle. So you could say it fires one particle in the direction. So you would want it all the way up. So it would be like you could say like from math dot. So you would have a uniform distribution from like math dot pi times 1.4 and math dot pi times 1.6. Um, and then what you could do is inside of, well, so you could have it as a particle system. This would give you into a actual recursive created particle system, which can be complicated. So I would actually make this just a polygon game object, and it's just like one game object. And it's in the upward direction, and then after some time, spawn a particle system. So this is kind of on the fly, but kind of the core. One thing you could do is fireworks. You would have like two game objects. You would have like the firework game object that like rises up into the sky, which would just be a polygon game object. And then after some time, you would destroy it, and you would spawn a particle system at that position of that game object that was launched up. And then it would kind of explode, and then you would have your variables, and you could include gravity, and you can include kind of that stuff. But if you guys are interested in that, I could do that next week. But yeah. So if you have any questions, comments, concerns, you could always email me. My email's on the syllabus. Otherwise, you could always talk to me after class.